How tall is that building you can't climb? How wide is a river you can't cross? Trigonometry answers questions like these using nothing but a right triangle and a few ratios. In this video, we'll build all 6 trig ratios from scratch, then nail down their exact values for the angles every exam loves: 30, 45, 60, and the ends 0 and 90. Let's start with the triangle. Take a right triangle and pick one of its acute angles. Call it A. Now name the 3 sides with respect to A. The side directly facing A is the opposite side. The side resting along A, that isn't the slanted long one, is the adjacent side. And the side facing the right angle, always the longest, is the hypotenuse. These 3 names are the whole game. Get them right and every ratio falls out. Now the 3 main ratios. Sine of A is opposite over hypotenuse. Cosine of A is adjacent over hypotenuse. And tangent of A is opposite over adjacent. A quick way to lock these in: sine ties the opposite to the hypotenuse, cosine ties the adjacent to the hypotenuse, and tangent skips the hypotenuse entirely. It's just opposite over adjacent. The other 3 ratios are simply the reciprocals, flipped upside down. Cosecant of A is 1 over sine, hypotenuse over opposite. Secant of A is 1 over cosine, hypotenuse over adjacent. And cotangent of A is 1 over tangent, adjacent over opposite. 2 relations worth memorizing: tangent of A equals sine over cosine, and cotangent of A equals cosine over sine. 3 facts before we use them. First, a trig ratio depends only on the angle, not on the size of the triangle. Blow the triangle up or shrink it, and because the triangles are similar, every ratio stays exactly the same. Second, sine A is one single symbol, meaning the sine of angle A. It is not sine multiplied by A. Third, since the hypotenuse is the longest side, sine and cosine can never exceed 1, while secant and cosecant are always at least 1. Let's use this. Suppose tangent of A is 4 over 3, and we want every other ratio. Tangent is opposite over adjacent, so let the opposite be 4k and the adjacent be 3k. Any common multiple works. By Pythagoras, the hypotenuse is the square root of 4k squared plus 3k squared, which is the square root of 25k squared. That's 5k. Now just read them off. Sine A is 4/5, cosine A is 3/5, cosecant is 5 over 4, secant is 5 over 3, and cotangent is 3 over 4. One more. If sine of A is 1/3, find cosine. Sine is opposite over hypotenuse, so the opposite is k, and the hypotenuse is 3k. The adjacent side is the square root of 3k squared minus k squared, which is the square root of 8 times k. That tidies to 2 root 2k. So cosine A, adjacent over hypotenuse, is 2 root 2 over 3. Notice the pattern. One known ratio plus Pythagoras gives you all the rest. So far, the ratios are general, but a handful of angles come up again and again, and you're expected to know their exact values cold, no calculator. Those angles are 0, 30, 45, 60, and 90 degrees. Here's the table and a trick so you never have to rote memorize it. Start with sine. Write the numbers 0, 1, 2, 3, 4. Put each under a square root and divide by 2. That gives root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Simplify and you get the sine values exactly. Sine 0 is 0, sine 30 is 1/2, sine 45 is 1 over root 2, sine 60 is root 3 over 2, and sine 90 is 1. As the angle grows from 0 to 90, sine climbs from 0 to 1. Cosine is the same list, just reversed. Cosine 0 is 1, cosine 30 is root 3 over 2, cosine 45 is 1 over root 2, cosine 60 is 1/2, and cosine 90 is 0. So as the angle grows, cosine falls from 1 to 0. For tangent, divide sine by cosine at each angle. Tangent 0 is 0, tangent 30 is 1 over root 3, tangent 45 is 1, tangent 60 is root 3, and tangent 90 is not defined, because cosine 90 is 0, and you can't divide by 0. The reciprocals follow straight away. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. So cosecant 30 is 2, secant 60 is 2, cotangent 45 is 1. And 4 of them are not defined because they'd need division by 0. tangent 90, cotangent 0, secant 90, and cosecant 0. Where does the table come from? 45 degrees comes from an isosceles right triangle with legs 1, 1, and hypotenuse root 2. 30 and 60 come from cutting an equilateral triangle in half, giving sides 1, root 3, and 2. 0 and 90 are the limiting cases as the triangle flattens or stands straight up. You don't need to derive them every time, but knowing where they come from means you can rebuild the table if you blank. Let's evaluate something. Scene 60, cosine 30 plus sine 30 cosine 60. Substitute from the table, root 3 over 2 times root 3 over 2 plus 1/2 times 1/2. The first product is 3/4, the second is 1/4. Add them and you get exactly 1, clean. A favorite exam type. Suppose sine of a minus b is 1/2 and cosine of a plus b is 1/2 with a greater than b. Sine of something is 1/2 at 30 degrees, so a minus b is 30. Cosine of something is 1/2 at 60 degrees, so a plus b is 60. Add the two equations. 2a is 90, so a is 45. Then b is 15. The table turned a trig problem into simple arithmetic. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds. Go. Read straight from the table. Sine 30 is 1/2 and cosine 60 is also 1/2. Their sum is 1/2 plus 1/2, which is 1. So the answer is 1. That's option C. Lock it in. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. The other three are their reciprocals. For the standard angles, remember the root 0 to 4 over 2 trick for sine, reverse it for cosine, and divide for tangent. Last challenge, it's on the screen. Don't say it aloud. Type your answer in the comments, and I'll pin the right one. That's the foundation of trigonometry, the 6 ratios and the values that unlock every problem. In the next video, we turn these into the 3 identities that let you prove and simplify anything. Free notes with 60 practice questions are in the description. Subscribe for the next chapter. This is Clarix. Keep going.